Mission by so grateful and Labrador Coast Guard. We are reading you loud and clear.
Hello, welcome to Sea Views, and I'm joined by Adam Parnell from Churt, my co-host. Hello, Adam, how are you?
Hello, Julia, and I was just about to say that's an excellent podcast voice you just put on there.
You like
I love
it?
Yeah.
Today, Adam and I are really excited because we're going to talk about something very interesting and very different. So we have Martin King, the Nuclear Systems Manager, and Paul Roberts, who's Senior Engineer at Naval Solutions. And we're going to be talking about nuclear fuels in maritime. So welcome,
nice to be here. Thank you,
Martin, and welcome, Paul.
Thank you, Julia and Adam. Thanks for having us.
Yeah, no, this is going to be a really interesting conversation because actually, when you think about it, nuclear propulsion on a ship just sounds so far out there, but actually it's a thing, right? So, and I don't think many people know about it. So I'm super interested in this one.
Yes.
And before we do, should we do the who are you and where do you come from type bit for both of you so that our listeners and viewers know who they're listening to?
My name is Martin King. And I'm the Nuclear Systems Manager at Naval Solutions. We're a relatively small company, startup, and I've been with the company for about probably slightly less than a year, approximately. I've spent my entire career pretty much in the nuclear submarine sector. So going way back when, after university, I joined the Ministry of Defence and did a stint there within various submarine platform teams. And then I ended up going to a couple of consultancies, one of them being Atkins, you probably would have heard of, and I was seconded into Rolls-Royce doing primary component design, primary component onto the reactor, that is. Then after about 6 years, I joined a company called Jacobs, which later became Momentum, and again, doing lots of nuclear submarine-related jobs, such as refit of submarines, safety case support, various design activities, etc. And then I did a little bit on the weapons program with Cavendish before joining this company. So I have had a very varied and broad career, but at the same time, it seems to be in one area, i.e. the submarine area. So hopefully that'll give a bit of a context as we talk more about this.
Yeah, Paul from Manchester. I've been at Naval Solutions now just over a year. I joined there straight after leaving the Navy. I was in the military since I was 16, 23 years within the submarine service. Served on a Stuart and Vanguard class submarines, and now I'm taking that experience that I've utilised within the services and using it in the civilian sector. Ultimately, putting to my experiences and giving guidance and consultance to other companies. And I've done a lot of work with safety cases within the last year as well. So yeah, I've learned so much about the civilian sector, but ultimately my skills are being utilised still for what I know when I was in the forces.
Fascinating backgrounds. Well, this should be really interesting then.
Yeah.
Okay. I'm going to start with a really naughty question. What is nuclear propulsion? What is it we're actually talking about, and how does it apply to shipping?
For somebody who doesn't know nuclear propulsion whatsoever, a nuclear reactor on a high scale is just a heat source, and that is used to heat water, which is then converted into steam. That steam is then pushed throughout whichever compartment you need, and then used with either main turbines as a propulsion method, or it's used in generators to generate electricity. It's obviously quite a complex system, but on a high scale, that's exactly what it is. It's just a big heat source.
Martin, what are your thoughts?
Well, as Paul said, yes, it's effectively a giant kettle. So if you try and imagine what a power propulsion train might look like in a conventional ship, you've got the boilers. They generate the steam and they drive the machinery and generate electricity, etc. So the only difference per se is the fact that the boilers we actually refer to as steam generators, So subtle terminology difference. And as Paul says, the water or coolant or whatever it may be, because there's different flavors of that, circulates through a circuit within said steam generators, in which case the heat is taken away. And then the coolant flows back to the reactor and it just goes round and round in a loop. Now, I do appreciate that's a very simplistic explanation, but in broad terms, that's all it is. The only well, not the only, but one of the complexities that comes with that is there are many, many different flavors of reactor, so to speak. So we often talk about PWRs, and that's very, very well known, especially in the submarine service, of course. But there are lots of other flavors. So you can have coolant, which is not necessarily water. You can have lead, molten lead, of course. You can have molten salt. There's different types of water, be it heavy water, light water. You can have gas. So the heat transfer medium is one of the key characteristics of the various flavors of reactor. So I'm sure you've probably heard, or your listeners would have heard, various terms banded around, such as PWRs, pressurized water, lead cooled, molten salt, molten metal. So every time that's mentioned, that's effectively referring to the heat transfer medium.
Well, that's really interesting, because when you started off talking about water and steam, I thought, hang on a minute, I'm old enough to my first ship was steam powered. And I'm thinking, well, hang on a minute, we're going back 40, 50 years, but just with a nuclear power source instead of coal. But then you went into, I didn't even know you could melt salt. That sounds like, that's got to be incredibly hot, I guess.
Yes, it is. Yeah, extremely hot. I mean, that type of reactor, and there's so many different benefits and disbenefits to all and the various different flavors. If you think about across the spectrum, so PWRs, if we just talk through them one by one, if you want to pick up on any interesting points. So PWRs are very well known, very proven technology, being used in the military for, it must be 60, 70 years now, I would say. Paul, shout up if I'm wrong, a long time since the 60s. However, they are pressurized, and they need to be pressurized because they do need to carry some heat, and obviously you can't be capped at 100 Celsius. You need much greater heat than that, so they have to be pressurized to prevent boiling. And then once you solve that problem, then you've got the issue of containment. So you need all these thick pressure vessels, and you need a reasonable extent of containment, because the objective is, of course, to keep all the nasty stuff in. What you certainly don't want is a breach and have radioactive material escape. So it's all very well and good, but then you start thinking about all these downstream effects. And also with pressurized water, you don't need, the ones that are used in military are relatively high or very highly enriched fuel. So they've got a high proportion of uranium, enriched uranium in. And of course, that's not good on a civilian vessel for non-proliferation purposes. So you can't have that. And if you did have that, which would be fine, then all of a sudden you've got to have a reasonable core life. You've got a very large reactor, and then that's no good either. So PWRs, great, but they are somewhat limited for civilian applications. Whereas if you think about things like molten salt, now these are the Gen 4 technologies. These are coming online. So these operate at low pressure. They have a really, really long fuel cycle, so they're very, very efficient. By which I mean that the fuel lasts a long time. It burns up slowly. Because of that, because of the type of fuel that they use as well. So I'm not sure if you've ever heard of TRISO. I forget what it stands for, but it's tiny little particulates. It's tristructural isotropic. That's it. Tiny little particulates almost, or kernels of fuel, and they are extremely difficult to destroy effectively or melt. So these type of reactors are intrinsically safe, even if you did have an overheat or start to get towards conditions which would typically point towards a meltdown. You're not going to melt these triso fuel kernels. So very, very robust in that respect. And then you've got, but the downside of that, of course, of the molten salt is you've got the way that they work. Some of them, they have the fuel actually dissolved in the coolant, which is no good, again, for safeguarding issues and proliferation. And the salt, the type of salt that's actually used, means that corrosion control can be complicated as well. So molten salt, really, really good, but they have some downsides. Gas cooled as well. So again, these are really good for fission product retention. They keep the nasty stuff in because they can use triso fuel. But again, they are pressurized. Not quite to the same extent, but it means that we have the same issues.
Yeah, so because the gas is the coolant, instead of what, like, PWR2 is heavily reliant on ensuring that coolant is in with the right specifications, so it needs a lot of chemistry regime over different various temperature ranges. With a gas-cooled reactor, you don't have that problem. Corrosion, etc.
Okay, so what I'm hearing is there's different, to use your word, Martin, different flavors of reactor, which will go on advantages and disadvantages. When it comes to maritime, what ones are under contention? Are they all a potential solution, or are there only one or two of those that are a good solution?
So there's the technology selection itself, and it's just like any other engineered system. You have to weigh up the pros and cons. But in doing so, you have to take into account safety and security, and you have to take into account how these things are going to be regulated. And then there's a whole load of stuff that kind of branches off that as well, like insurance, or that kind of thing. Insurance is a big one, and how these things actually operate. So to say whether there's a front runner in contention, I would say I'd be very disingenuous if I were to say there's one particular which really stood out, but I would say PWRs are almost certainly not appropriate, largely due to the reasons I outlined with respect to non-proliferation. If you want to have a reasonably power-dense reactor, then you need to have relatively highly enriched uranium, which is going to be an absolute no-no with respect to non-proliferation agreements. With the other ones, so molten salt, that one probably has an edge over the molten lead. But all these new technologies which are coming online, it's almost like a box of chocolates. There's so many you could choose from now, and there's so many competing ideas, and they've all got the kind of stuff that we really look for. So we've got the passive safety and the intrinsic safety. So the operator can effectively walk away, and they have relatively modest levels of enrichment, so we don't have to worry about the safeguarding aspects. So technologically, I think we're fairly well placed collectively, I would say. But if you're asking me personally, I would say molten salt might have the edge. But like I said, it would be disingenuous if I were to try and suggest a front runner.
I mean, it's interesting. What is this applications for commercial maritime? Does that mean that it would be a completely different system to what the military have been using?
They wouldn't go with the PWR2. It's costly. Takes a lot of maintenance, a lot of training, through life safety, where I think the ultimate solution here, like whichever reactor you choose, is something that's easily to adapt to different types of vessels throughout the world. It could be on an oil tanker, it could be on a merchant ship, it could be on a super yacht. It's just something that's small, powerful, safe, and doesn't need a lot of maintenance. And that is what I think ultimately they are trying to get to, that point where they can just bring something like a micro reactor on the back of a lorry, put it on a ship, and then it just the challenge is, like, obviously integrating it with the systems on these ships, or you build it to spec with a whole new design and regime of what you want to achieve. But ultimately the challenge is like basically connecting this reactor to the systems that are on the vessels and how it'll work together, because they might be used for different things. You know, you might just have one just for the power source of the vessel. You might have one for the propulsion. We just don't know yet. But there's so many diverse different thoughts out there on how they're going to do this. We just want to get to the point now where we actually put something on paper and say, this is how it's done. This is what you need to do it. And basically be the forefront in saying this can be achieved, because there's a lot of tepid people out there, isn't in the Martin, who just don't want to commit to it.
Yeah, absolutely. And I think, just to expand on one of Paul's points, is I think looking at all the various technologies that are out there or emerging, I think standardization is going to be a big part of this. So if we think about some of the front runners, I won't name any specifically, because it is available online. But think about some of these front runners. If they're developing maritime reactors, they're probably going to find themselves in a good marketplace for when the time comes, and it will come. Believe me, I think with the various imperative to reduce greenhouse gas emissions within the next 25 years, this will most certainly play part of that mix. I think whoever can and have something which is scalable, readily deployable, standardized, modular, there's a whole host of various buzzwords, but we'll have a good foothold in the market. I'm sure of that.
Interesting. So you've both, between you, raised actually quite a few points. I'll just pick on one to start with. When we say micro reactor, Paul, paint a picture for us, because the only image in my head of a nuclear reactor is a civilian one, which is normally a massive building. Yeah, huge. Obviously, clearly not going to fit on a vessel, even something as large as a sort of super type thing. But so we
literally there are designs throughout the world now where these things could be put on the back of a lorry and transported to site. That small, and it'd be like PWR2 on submarines and the American fleet. You could really class them as micro, because they are no bigger than a wheelie bin. You know, when the RPV body itself. No, they are small in size. It's just I think people they don't really tap into this, do they? They see like TV shows and they see things that have gone wrong with nuclear plants, and they see big vast plants, and it's like anything. Technology has advanced so much within the last 20 years that these things now are literally, you could potentially put them on the back of a lorry, transport them to site and refit or change. There's a couple of micros in the US at the minute where one does fit on the back of the lorry and one comes in a few components, and then they can build.
Oh, that's interesting. So there's obviously some real uses in the military, because as I understand, obviously you can get a huge amount of power, and you've got the stealth endurance element where you can be down operating for months and months. I'm not a nuclear physicist, but what will be the benefits for maritime sort of commercially then in using nuclear? Is it just the decarbonisation, or is it other advantages in the long run of the life of the ship?
Go on, Martin, have you ready?
I think there's a couple of things. If Paul might want to interject, and that's fine. There's again, I like to do things in threes. So I've mentioned the decarbonisation already, and I think that's going to be an imperative. So with all nuclear technologies, they are zero greenhouse gas emissions at the point of use. Now, I do recognise there are some subtleties with that when you think about all the front end emissions, so to speak. So you've got the mining and construction, mining for fuel and processing, and the construction of these things themselves. And I do recognise there is some front loading there. But if you take that across it has been well proven and well documented. If you take it across the entire life cycle of a reactor, then they are lower carbon alternatives than other fuels, for example. So thinking about LNG or biofuels or synthetic fuels, and again, the same applies for them. I think they're very good. I'm not throwing stones at all. It's just that those things like hydrogen, ammonia, they're not necessarily as power dense, and they don't have the scalability factor. They're not as energy dense, and they're not necessarily lower emission either. Again, because you've got to synthesize these things. So, I think the decarbonisation is, and this is good. This is going to be statutory, of course. So, I think that is an absolute imperative. Then the second kind of bit is Paul just mentioned the economics and the endurance. So, from an endurance point of view, these things just keep going. You don't need to slow steam. You don't need to, and they just, like I said, they just keep on going. So you can go backwards and forwards, full whack. And in very remote locations, because of course you don't have to refuel, bunkering, shall I say. And that opens up new markets potentially. So I think about cruise destinations potentially. That could be something brand new. Or if it's some kind of cargo vessel, you can go backwards and forwards all day long at high speed. And it makes absolutely no difference whatsoever, because you don't have to be concerned about, we're going to make it, or we've got to be able to carry enough cargo without the usual recourse to making ships ever larger, ever bigger. So it provides the operational flexibility as well. So what was it? Oh yes.
Well, you're in threes. You definitely like your threes, Martin.
Yes, I just. I was thinking I like to do things in threes, and then we've got the technology base, of course. So there's a huge amount of learning from the military, and it's really important to recognise that everything that's coming online, whilst the technology is new and the principles are absolute. It's all been done before. So I'm sure we can talk about some of the lessons learned from the military sector, but you can't just pick up a military reactor and put it on a commercial vessel. No, you can't do that. But the principles are the same. The design principles and the principles of operation are largely the same, notwithstanding some of the walkaway and passive safety that some of the new benefits. And then if you think about the regulatory environment, which is obviously going to catch up, it will come with time. That is starting to be looked at by the IMO. So it will get there eventually, and I think it's really being driven from that greenhouse gas reduction imperative. So that would be my kind of take on it at the moment.
Well, what about the economic imperative? I mean,
for me, if it was my business model and I was doing it, and I've said this to Martin before, I think of it's like planes and Boeing engines. Like the plane companies hire the engines, the technology, the maintenance procedures, from Rolls-Royce. And I foresee that's happening with the maritime sector as well. People build these and they basically loan them out to the companies. I don't know how much, but I don't foresee that they'll buy them and keep them and replace them. I think it will be more of like the company owns the technology, because ultimately you wouldn't be able to train the personnel to maintain these on site at all times. You'd probably go to ports, and then the crews from the company, the design engineers from the companies would come and maintain them, and you just need operators on board who are equipped to conduct that evolution. I can only foresee that being the best thing, because if you buy it, then you take all the risk on owning it and maintaining it as well. And like the companies will have to train their own people through, which doesn't exist out of the defence sector or large companies such, as Rolls-Royce, etc., to train these people and be independent on their own ships. I just can't envisage that happening.
Yeah, and I can see like with the Rolls-Royce model where the aircraft company, the airlines release the engines, but Rolls-Royce monitor all the engines that are flying at any time, and they've got all that information. They do all the engineering, all the fixing. They've got all that expertise, and that would work across, say, rather than just your own shipping fleet, it would be across all the nuclear engines that you actually had out there. So I can see why that would make a lot of sense.
I don't know the commercial aspects of purchasing it from Rolls-Royce, but I do know that Rolls-Royce are on site at all times to provide support, so to maintain these, and they're an overseer as well for the assurance of the plan when it's alongside and at sea.
I feel like I should put on my best BBC voice and say that other models are available.
Just speaking freely, like if you design something which, like we have to be honest, potentially if it wasn't maintained correctly through life and an accident happened, you don't want that with like falling back to your company, do you? And I doubt anyone would give it the assurance to give it a 25-year lifespan on a ship without being maintained, unless it was an incredible piece of equipment.
Well, that's actually a good point you raise. I mean, what is the lifespan of your...
They all change. It depends how much fuel's in it. It ultimately depends how much fuel's in it. And the enrichment, yeah.
Oh,
mm-hmm. I mean, enrichments as well. So, you know how I was talking earlier about various levels of enrichment. It's all a bit of a trade-off. So the core life is very much dependent on the fuel, the level of enrichment. And if you have a relatively low enrichment, then you might want to make your reactor quite literally bigger, physically larger. So there's lots of different balances to be struck.
I mean, take maritime as industry as it is, you know, and a vessel that's over about 15, 18 years old is considered, you know, old. Even though they've probably got, in terms of physical engineering, you know, and hull thickness, etc., they've probably got many, many years left. So I'm talking potentially about using Paul's hire model. You hire it for the life of that vessel. It comes out, gets refurbished, and puts back into another one. Are we talking about something that gets repeated over and over again, or do these things only last themselves 20, 25 years, or I know that's how one's piece of string, but just to sort of...
Yeah, I would say that treating it... I'm not saying it will never happen, but I think treating it as almost like a battery is probably not the right analogy. I think from what I can tell for the technologies now, they would almost certainly have to be fully decommissioned. However, again, it's an interesting idea. I mean, to be honest with you, Adam, I haven't given it a lot of thought. You would have to probably reach out to the vendors to find out more about that, because I think in truth, I don't really know. But certainly from what I can see, I would suggest that they have to be fully decommissioned, which of course brings up the aspect of having the necessary infrastructure to do so. You can't just do this any old where. Any old port. So, yeah, it's an interesting one. Truthfully, I don't know. But if it were to be possible, and it might well be something that vendors look at, then it would certainly ease the burden in terms of infrastructure. That's for sure.
And that brings, I guess, its own challenge of not every country has that infrastructure, nor potentially even just some countries have that nuclear engineering capacity.
Is the answer?
Organically.
And that's where I probably think, like, again, like the business model of renting out the reactors to ships, probably the ships will get rented out to countries as well. It'll be a chain of events, I think, that start from the design engineers, and then the operators will lease their fleets out to other flag states.
Well, that model for me answers many questions, because I was going to bombard you with, like, okay, what do you do about training?
Yes.
How do you make sure people are current? How do you do assurance? But you've sort of answered a lot of those questions.
If you just bought a nuclear plant yourself, and you'd have to do it, but only from what I know within the services. But that model that I've envisioned, I can only see that being the only logical thing to do.
That makes sense. And I guess one of the commercial sweeteners is that, as Martin alluded to, you know, you're not spending time doing bunkering. And if you add up all the hours here and hours there throughout the life of a vessel, that's quite a lot of sailing time that you've...
Another challenge that we've got coming that will be is the safety case aspect of it. Because the reactor's going to, let's say the power source, let's say the black box, whatever goes on the ship will have its own safety case. The ship will have its own safety case. The port that it goes to will have its own safety case. Yeah. And these all need to talk to each other and work with each other. So yeah, that definitely will be a challenge, because I think, like I say, you're going to have many, 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 many variants of ships that take these in the future. And 20, 30 years time, I think the whole scene will be completely different.
So you're talking, and you mentioned earlier, even down as small as, I say small in a relative sense, down to super yachts. So you are talking relatively small vessels. We're not just talking about the huge container ships or tankers, are we? Well, that have the room. So these things are going to potentially be going all around the world. What are the? Well, we've talked about lots of challenges. Let's talk a little bit about the risks. The most obvious one clearly being radiation or And if something untoward was to happen to the vessel, grounding, capsize, sinking, whatever,
Fire.
what are the fire? Yeah, all the usual things. What are the implications would that be?
Well, that's one of the stipulations with Gen 4 reactors, which is predominantly the reactors that are going in these vessels, that they have do intrinsic safeguards. That one of these eventualities did happen, they can basically shut themselves down, melt the fuel instantly, and cool itself, and make it dormant within seconds. But we don't have that within PWR2.
Okay.
Oh wow! Okay.
We don't have that luxury.
The Fukushima type event, then, where the thing gets covered in water or something untoward happens in it.
Is it like an ice? It's like I can't remember what it's called, like a plug or something, isn't it?
Yeah, it's molten salts have a. I know what you feel, a plug, effectively, of solidified material. And if you get to the conditions where you have an accident condition where you're leading to or heading towards, let's say, a meltdown, then that plug will melt and drain the fuel away into dump tanks. So that's quite a good feature of the MSRs, for example. So it just takes the fuel away. I think some of the accident scenarios that you've mentioned, like sinking, for example, I mean, that's, whichever way you look at that, that's pretty bad. I don't know what happened, because some submarines have some nuclear submarines have sunk in the past. I don't know what the environmental implications were. Probably, I'll be honest, they're probably not great. Probably not as bad as people would think either. So yeah, I think collisions and groundings. I mean, we've got a lot of these are maritime specific hazards, but we can learn from that from the military sector. So we do have robust designs against shock, and we do have robust reinforced areas against collisions and groundings. Sinking, in the event of a sinking, low probability that is, that there's no, you can't really pull any punches with that. It would be pretty bad. And this, of course, leads on to the issue with insurance, who would actually accept liability for that. And regrettably, right now there is no international framework. So, although intuitively it seems all right, operator is liable here. I think this is probably one of the reasons, from a commercial standpoint, more than anything else, that these things aren't picking up right now. I think insurance is a big one. Who actually accepts the liability? Because at the moment it's not entirely clear at all.
Well, I'm imagining what we're talking about. If you're talking P&I clubs, you're talking about pooled. You're going over the threshold for it to be a pooled case.
Well over. Yeah. Oh, yeah.
But then that happens if you have, an Exxon Valdez type thing where you've got a huge oil slick, which can, in the wrong area, can cost hundreds of millions, if not billions. But you hope that these are one-off events, right? Okay, so one of the things as well, I guess, and you've alluded to it, both of you, is I guess perception. A lot of the take up. I can understand the hesitancy, because with assent there being international standards and use cases, and as Paul said earlier about the integration of all the different use cases and safety cases from port through to and all stages in between. There are a lot of physical hurdles to overcome, but also perception hurdles, I guess.
Yeah, definitely. I was going to say, so this is what I think is sometimes termed a social license. So you can effectively, you can have legislation for safety, liability. You can have all the relevant regulation. You can have all the evidence to prove that you've satisfied said safety and legislation. But when it actually comes to how people feel about it, it's a real hearts and minds thing. So it sounds great in principle, but some people might not necessarily feel happy, let's be honest, if they've got a multi-megawatt reactor. If they've got the nice apartment by the sea and a port, and they've got 500 meters away, like I say, multi-megawatt reactor in a busy city centre. So it's, I do think over the years the perception of nuclear is becoming more favourable, but it doesn't take much to undo that or have a negative effect. So I've got to bear in mind that it would probably be only maybe a one. I'm trying to think of the right phrasing here. So, when this becomes more mainstream, nuclear shipping, that is, it would not take many, if not only one, accident to pretty much end it, I think. So that is how robust I think that social license needs to be. It needs to be 100% as near as, damn it, cast iron level of trust. It really does. Otherwise, it will quite possibly end it before it's begun.
Yeah, we might be in a much better position now, given what's happening with fossil fuels and, I suppose that's another point about the waste element, because that's been in public perception. That's been one of the issues in terms of the spent waste, which has been quite a problem. But I understand that has improved with modern technology. So you talk about decommissioning.
There is talks at the minute
systems.
Like these will not be built without a full-on decommissioning program, like assured within the country or residence that they're getting built in. There are multiple conversations going on now with like the big wigs within this sector, but there are many options, and to nail one down, I couldn't give you one right now, but it definitely is in discussion, and it will not go forward until it's clarified in the way what the intent is with that. Do you know any more on that, Martin?
No. Although I do agree, I don't think I was talking about lessons learned from the naval program. I think certainly within the UK, I think we accept that things could have been better, and the decommissioning of submarines is far later than would have ideally been envisaged. But it is finally starting to gain some traction, slowly but surely. Again, for any kind of scale on the commercial front, we can't afford to do that. We can't afford to do that. So I think Paul's absolutely right there. This has to be looked at throughout the entire life cycle. We can't start pumping these things out and then having absolutely no idea about how they're going to be decommissioned. And just going back to the point mentioned earlier, I think Adam raised it with respect to infrastructure. Where's the waste going to go? How's that going to be controlled and regulated? And again, that'll probably have to be a nuclear state, and all the administration that goes with that. So it's ultimately the only way I know what they will do is they'll either pool them or concrete them. It's still uranium at the end of the day. We've got processes that throughout the world that deal with that at the minute. We know what to do with it. We just probably need sites where to put it.
Yeah. Okay. I mean, looking at the future then, and you touched on this a bit, what do you both see as the future, or what needs to happen, or what do you hope for the future for this source of energy in maritime?
What I hope is that people start committing now and putting the financials forward to actually doing this on paper, because for the last few years, a lot of people have just been talking about it and envisaging it, but it really does need that person, that company, that government, country to take that step and build it and deliver it. You know, there are nuclear floating vessels within the world at the minute, but from what I envisage within the next 20 to 30 years, where you literally have oil tankers, merchant vessels, yachts, all forms of ships to have small micro mini reactors within them, and they all speak harmoniously across each other, and it's not a complicated science or future. We just need to nail it down and just be consistent across the globe on what we're doing. And we can't do this country by country. It does have to be a worldwide thing, and everyone needs to be on board, because ultimately they will be sailing to ports. So yeah, it's a global change. Yes, absolutely. It's a global change that needs to be done, and a change in mentality to actually take the steps forward and commit to doing it, because something has to change soon.
Yeah, but the good news is, Julia, I am aware that the ship design committee recently, I think it was probably not that long ago, January time, was discussed at the IMO Ship Design Committee. Sorry, just to be clear, was discussing this very, very recently. So just picking up on Paul's point about regulatory harmonisation, it is happening. It is happening. It's going to take a long time, but it is happening, which is really, really promising. So I think there's two strands, really, isn't there? There's the technological strand, so about selecting the right technology and looking at a test case, perhaps, or the right ship type and the right operational profile. And then parallel to that, there's the regulation standards development, which the IMO are looking at now. Also the IAEA, there's got to be a bridge between them. Obviously, the IAEA are the international nuclear regulators, effectively. So they are started to work together to develop that global standard. And I think once these two things are working in parallel, it's just that inertia more than anything else. It just takes time to get these things going. And the technology's there. Technologically, we're definitely really right on the cusp now, I would say.
On the horizon.
One of the things I did when I was sort of researching this was, I think it's the Nuclear Energy Maritime Organization, NEMO, which I'd never heard of, but it's a cracking acronym. Has I think IMO or some form of status at the IMO now. So they're obviously moves afoot, and it sounds like the IMO are tackling this as a live issue. It isn't one of these things. It's not a tomorrow problem, is it? It's being looked at today.
Yeah, absolutely. Absolutely.
I really want to ask Paul from the lived experience of being on a vessel that's powered by nuclear. If you had your choice, would you like to serve on a ship with a big, noisy, vibrating kind of diesel propulsion engine? Or, have you actually seen the benefits of being on a nuclear-powered vessel, which I imagine is quieter and less smelly?
Ultimately, from my lived experience, I've only ever served on nuclear submarines. So I could obviously imagine what it's like to work on a loud diesel submarine surfacing every few weeks to charge the batteries, etc. But yeah, there's the upsides and the downsides of it. Like operating at sea is quiet. It maintains itself. You don't do any maintenance on it. It works perfectly. You would very, very rarely have any defects on it. It's the burden when you come alongside and the amount of maintenance that needs to be done on it and the time it takes. You can't just go down the RC and start working on it. There's like special procedures. You need nuclear safety inspectors to come down and work with you. You need quality assurance after it. The paperwork trail is quite substantial for everything that you do, which is rightly so. It's it's a nuclear reactor and these are special materials. But yeah, that's the only thing. Like the maintenance on it is a lot more harder and challenging. But rightly so.
Yeah.
But the technology, But then the technology which would move on to the next.
Yeah, exactly. I envisage a perfect thing would be like, I don't keep saying it, but like a small reactor that's put on the ship and it's easy connectable to the ship's systems. It's quite a cross ship thing, and you don't have all these challenges with maintaining the secondary systems that you do with submarines, because ultimately it's all interconnected together. Like whoever builds a reactor maintains and operates that part of it when it comes alongside, and then the ship's crew just operate and maintain all the secondary systems as they would on any other ship, without the additional skills and methods needed to maintain nuclear equipment.
That's been so interesting.
Me too.
We're all learning, and some really interesting things coming in the future. And anything else you wanted to ask, Adam, while we've got our guys here?
Do you know what? No, I mean, well, yes and no. But actually, as a sort of an introduction to the topic, guys, that was amazing.
Yeah.
That's really, and I'm blown away by the fact that we're talking lorry-borne as opposed to, a high-rise block of flats type size things that which is my only frame of reference.
Yes.
Yeah, it's amazing. If you had a crystal ball, when do you think this is going to be seen in anger at sea? 10 years, 15 years? We're sort of.
I'll go first on this one. So, I as I mentioned earlier, there's definitely an imperative, but technologically, like I said, I think we're there. or very close. From a regulatory perspective and insurance, I think it's that little bit further away. So my stress personal prediction will be about 5 to 10 years. So that, yeah.
Okay.
Which is still pretty quick.
Which is still reasonably quick, but I think certainly over the next couple of years, I think the urgency and the pace will pick up. So it'll be interesting to see. I don't know. Nobody's got a crystal ball. And we don't have all the answers, unfortunately, but we will see.
If we're still I hope we're still doing sea views. We definitely come back to this in a couple of years and see what's moving on.
Yeah.
It's really interesting. Thanks so much for sharing your expertise, Martin and Paul.
No, thank you for having us.
That's been quite mind-blowing. We will leave the bridge now
Thank you very much.
And thank you
Cheers.
so much for your time.
Yeah, thank you so much.
Thank you.
Thank you.
Thank you.
Fishing vessel Great Falls Labrador Coast Guard, we are reading you out and clear.